Hello everyone, we will start now. I hope everyone has my attention. Good afternoon to everyone joining us from different parts of the world. A very warm welcome to day 3 of the 5th International Conference on Universal Threats in Expert Applications and Solutions, or as we fondly call it, UNI-TEAS 2026. My name is Mehul Girdhar and it is an absolute pleasure to moderate today's online session. This prestigious conference is being organized by Shree KKarni Universe College, Apex University, and Panipat Institute of Engineering and Technology, managed by KK Consultancy Services, India, and supported by University of Rajasthan, ACM Jaipur Chapter, All India Council for Technical Education, and Computer Society of India Jaipur Chapter. This year, we have received an overwhelming response with over 300 paper submissions from across the globe. After filtering out AI generated and plagiarized content and a rigorous peer review process by our expert panel, only the top 80 papers were selected for presentation. Based on their performance and the recommendations of our chair session, these selected papers will be published by Springer Nature. On the day 3rd, we carry forward that same enthusiasm, ready to dive deeper into thought provoking sessions and interactive presentations that will continue to shape the future of intelligent systems and digital security. With that, I am pleased to introduce our session chair for this segment, Mrs. Vijeta Kumawat, professor at JECRC Foundation, Jaipur. Session number chair 2, Mr. Sumeet Gill, professor at Maharshi Dayanand University, Rohtak, Haryana. Session number 3, session chair 3, Mr. M. Firdos Sheikh, associate professor at Poornima University, Jaipur. And before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth, timely session. Each presenter has 10 minutes to present. Please stay within the time limit. Briefly cover your research context, objectives, methodologies, key findings, and a conclusion. A short Q&A may follow your talk of 1 to 2 minutes. Keep the responses brief and focused. Keep your mic muted when not speaking and stay for full session to support the fellow presenters. Now, with the kind permission of our session chair, we shall now proceed with the paper presentations. I would like to invite our first presenter of the day, presenting the paper titled A Deep Learning Framework for Sentiment Classification of Tweets Using CNN Attention Hybrid Model under the code 405. I just request Mr. Pranjal Negi to kindly take the virtual stage and begin the presentation. Over to you.
A very good afternoon to everyone. Am I audible?
Yes.
Okay, ma'am. I'll be sharing my screen now. So is it visible to everyone?
Yes, it is.
Okay, a very good afternoon to everyone. I'm Pranjal Negi from the Pranjal Institute of Technology. Today, I'll be presenting a paper on developing a deep learning framework for sentiment
Sorry to
classification.
disturb, Pranjal. Can you switch on your camera?
Sure, sir.
Yeah, sure.
Am I visible?
Yes.
Okay, thank you, sir. So should I begin with? Yeah. The topic is deep learning framework for sentiment analysis of tweets using CNN and attention hybrid model. Coming to our introduction, main part, Twitter has become a crucial for expressing very crucial for expressing opinions instantly. Sentiment analysis on tweets is vital for major marketing, politics research, and social research too. However, tweets as tweets which are present today present unique challenges. Basic of them are they're informal, short, filled with slangs, emojis, and misspellings, making traditional NLP's method inadequate for accurate classification. So, so this is our introduction. Coming to a research problem, we are addressing the classification of speech into positive, neutral, and negative sentiments. Traditional machine learning models use bag of words struggle with social media text because they rely on manual features that mostly miss contextual and emotional nuances. We need models that both classify accurately and explain their predictions. So our proposed solution to this is a hybrid CNN attention model combining strength of both architectures. The architectures that they're using is uh, uh, one solution combines CNN with attention mechanisms. CNN layers extract local text features and patterns, while attention mechanisms focuses on sentiment-relevant words. This hybrid approach provides both improved security and interpretability. So this is our data set. Our total data set, we used 27480 labeled tweets from Kaggle. The data set is relatively balanced. 11117 neutral, 8582 positive, and 7781 negative tweets. This distribution prevents class bias and ensures effective learning across all sentiment categories. So our pre-processing pipeline, this is a pre-processing part. Our pre-processing pipeline remove null value first. Then we use spacey for text cleaning and lemmatization. We removed non-alphabetical characters, URLs, and stop words. Finally, applied Keras, tokenizer, and sequence padding to create uniform inputs. So coming to next, model architecture. The architecture starts with an embedding layer transforming word sequences into dense vectors. 1-dimensional convolution layer with ReLU activation extracts local features, followed by max pooling to reduce dimensionality. The key innovation is the multi-head attention layer. This is a multi-head attention layer, enabling focus on only important sentiment words. Dense layers with dropout and softmax activation complete the multi-class classification. So our training configuration, this is we used Adam Optimizer with sparse categorical cross entropy loss. Training ran for 5 epochs with a batch size of 64 and 20% validation spread, a configuration, balancing training, and performance. So this is our result overview. So our model achieved 93.2 training accuracy, demonstrating excellent learning capability. Validation accuracy of 78.5 shows good generalization. A test accuracy of 55.91 indicates room for improvement with completely unseen data, but overall demonstrates effectiveness. So this is our model learning behavior graphs. The model had an upward trend in training accuracy, which shows good learning in the sentiment patterns. Improvement was rapid, specifically between first and third epoch. Training validity flattened after fourth epoch, indicating model had already learned. Another good sign that it is steady is the steady rise of training accuracy along with unchanged validation accuracy, which points that the architecture was not overfitted with. So this is our training and validation accuracy curves. This performance rates the model as a very appropriate candidate in terms of sentiment analysis in social media, where concise text prevails and spread of response is primary importance. So coming to next part, our key findings. Key findings, the 93.2% training accuracy proves our model captures sentiment patterns effectively. 78.5 train validation accuracy indicates reliable generalization, while test accuracy shows improvement potential. A hybrid approach significantly outperforms the traditional methods. So our model advantages, our model offers distinct advantages. The attention mechanism provides interpretability, which means like we can show why a word is why a word is important by showing which words influence predictions, crucial for building trust. It handles informal informal social media language, including slangs, abbreviations. Compared to large transformer networks, it's more computationally efficient by delivering strong performance. So, real-world applications. This has practical application in brand tracking and reputation management, political sentiment analysis during election, public opinion analysis for decision making, which is obviously data-driven decision making, and real-time social media monitoring. The model's efficiency make it suitable for large-scale real-time application. Future work. Future improvements include integrating pre-trained embeddings like BERT to handle out-of-vocabulary words better, applying data augmentation for improved generalization, experimentation with transformer architectures, and enhancing sarcasm with and irony detection capabilities. Coming to conclusion, to conclude, we successfully developed a CNN and attention hybrid model, providing model achieving with our model achieving a 93.2 training and 78.5% validation accuracy. The attention mechanism provides interpretability for understanding prediction. This presents a promising solution for real-time sentiment analysis, balancing accuracy and interpretability, and computation efficiency. So that's it. Thank you for your precious time, everyone.
Thank you so much, Mr. Pranjal Negi, for your insightful and well-articulated presentation. We are open to questions now from the audience and the
Yes,
Q&A
Pranjal.
sessions.
Yes, sir. Am I audible?
I'm having. Am I audible?
Yes, yes.
So I'm having two
Yes,
questions.
sir.
The very first question is, why did you choose a CNN attention hybrid model instead of using only CNN or RNN for sentiment classification?
Yes, sir. So our
So why you choose CNN attention hybrid model?
yes, sir. The main the CNN models was used because wait, I think the camera. Yes, sir. So we use CNN an attention mechanism model because normal NLP models, they are good with normal data, but in social media data like Twitter data and all, we have slangs, we have many informal language that is being used. So CNN tends to capture these patterns better than the text processing techniques, and attention mechanism was used. So we can point out specific slangs that are important for predicting our like that are specific to predicting our output.
So in the tweet classification,
Yes, sir.
like some challenges like emojis, hashtag, short text length. So how do you handle these types of challenges?
Yes, sir. So there are challenges like emoji challenge. So firstly, we tried to like. So in this model, in pre-processing we removed the emojis part, and we primarily focus on the main phrases like that avoid combinations that are being used as sarcasm or in informal languages or like slangs and all. We primarily focused on them, like their combination, like how are they how are their sentiment. So we technically removed the emojis and yes,
which what evaluation metrics did you use? Like accuracy, precision, F1 score. Which metrics did you use
which
in your sentiment analysis?
which matrix did we use? So we use
Yeah.
yes, sir.
Yes. Which evaluation metrics? Na? Like recall, so many factors are there, F1 score are
precise
there,
recall and
accuracy
everyone.
are there. So which type of metrics you did use?
Yeah, sir, the basic which contains F1 score, precise recall, and yeah.
Okay, thank you so much for my side.
Thank you, sir.
What about the data you used in your research?
Ma'am, the data was taken from Kaggle. So because informal data is mostly not present as like we have to make balanced data. Like, so it doesn't create a bias. So we mostly took our data from Kaggle.
Okay, sir.
All right, I guess we're done with the questions. Now it is time for presentation titled Explainable Multimodal Deep Learning for Spatio-Temporal Forecasting of Groundwater under the code 417. I request Mrs. Kaushiki Tripathi to initiate on this virtual stage and begin the presentation. Over to you.
Good afternoon. That will be a miss for me.
I request Pranjal Negi to remove the presentation from the screen.
Right.
Thank you.
Good afternoon, everyone. Today, I will be presenting the review paper which we have done on explainable multimodal deep learning for spatiotemporal forecasting. The major motivation behind this paper was to collect data and gather all the information on how exactly can different studies on the groundwater levels and their depletion be taken together in order to make a successful AI model in future. So this is majorly a review, and the model is actually the future scope of this paper. As a strategic natural resource, it has been depleting profoundly over the past few decades. Not only that, but even in the areas where groundwater is present, especially in North India, it has been majorly polluted, which brings us to different situations in which the forecasting itself is very difficult. As the different factors, evapotranspiration, groundwater abstraction, pollutions, and overexploitation are majorly clashing with each other. It has data from majorly government websites. The model complexity is high because it has multimodal architecture. CNNs are used for satellite imagery, LSTMs are used for tabular data, and Modflow and SWOT have been widely used for groundwater simulation. We had a very strict study selection criteria, as only the articles published between 2023 to 2025 were prioritized. I won't say considered, just prioritized, because there were some before 2023 as well that were important to our multimodal fusion. Explainable AI did not see much. Did not feature much in the previous papers, but has been in the new ones. The reason why we added explainable AI to the study was because the reusing of studies and researchers was very low, especially in AI, because of the accountability which papers or studies did not provide. Explainable AI just provides us a transparent we can say interface to see how exactly studies went about, so that others can take on from it. Some of the studies actually lack predictive modeling. They did not focus on groundwater forecasting, and they lacked sufficient methodological detail for evaluation. Such were given away. And at least one ML or DL model had to be used in each of the study for us to consider it in this review. These were the many studies that we had, and the highest amount of them had multimodal integration, but lacked explainable AI. As you can see, SHAP and XAI are only featuring in 2 or 3 of these literature reviews, in comparison with GIS ML integrations, which can be seen more densely. Research gaps, multimodal integration was not, I would say, humbly provided, as sometimes the data was majorly unreliable or having heavy noise in it. It was data scarce because the government sources were not used. It was mainly taken from Kaggle or any other readily supported data place. The data was not feature engineered by the people themselves, I would say, but readily taken. Instead, this project would rather need an independent database of itself, either on relational-based database models instead of NoSQL. And the decision support which it provided was not good because the prediction was always emphasized over it. Decision support needs to be better because here we are trying to build a foundation for better forecasting. So prediction alone cannot be the final goal, as it will definitely put us in a bad position over the inputs that we are giving. Our research objectives were majorly to synthesize multimodal groundwater forecasting, assess the model capabilities, compare AI and deep learning architectures, which I showed you in the literature review slides, and get the directions for decision-oriented groundwater forecasting over precision. End-to-end multimodal data across climate, satellite, GIS resources remains undeveloped area in this research. Current models struggle generalization especially with hydrological heterogeneous data like North India, which is the reason why we chose the region of North India itself. And the graph here shows the year-wise distribution of studies. As you can see, 2024 saw a mass number of studies in this, whereas before 2022 or 2023, such researches were not published much. These are the different sort of models that were used in these researches: GRU, CNN, LSTM, and the number of researches which had happened. AI-based models were really profound in 2024. Additionally, those studies are accountable to how multimodal data improve model robustness, because the combination of satellite data, land use, tabular data schemas actually gave us better decidability, if not the precision, and explainability methods gave us a transparent interface for the research to stand accountable for itself. Concluding to it, I have that recent advances clearly demonstrate that deep learning models are more effective than normal ML models, and especially when it comes to data integration, which has numerous features like climate, groundwater, soil use. Growing adoption of explainable AI has also been seen. Literature review, the slides we showed, had a clear shift from purely accuracy-driven models to more interpretable, application-oriented groundwater frameworks. That will be all from my side. Over to the moderator.
Thank you for a clear and insightful presentation. You made a complex topic accessible. We are now open to the questions.
Kaushiki, am I audible?
Yes.
So my
Yes, sir.
question is very simple. Which AI technique did you use to interpret your model's prediction? Which AI technique?
Which AI?
Like Lime, Shape, so many AI techniques, na? So which AI techniques did you use?
So apparently, as I just mentioned here, this was a review of all the studies. The actual AI model is a future work here, right? We did not train any model here, if the training framework is what you are asking, but we are looking forward to have a combination of LSTM and CNN.
Okay, my last question. What are the major challenges in the forecasting groundwater depletion in North India? And how does you propose your this framework address them? Did you understand my question?
Could you repeat it?
Yeah. What are the major challenges in forecasting groundwater depletion in North India? And how does you proposed framework address of them?
Okay, so the first first of all, the way we addressed it, because we have a multi-model framework, it integrates temporal groundwater data, climate variables, spatial environmental features, right? And that having a unified architecture. Now, long-term spatial temporal representation was one of the challenges. Finding a reliable and what you can say clean data set was also a major challenge, as I said, which is why these kind of studies need an independent data set of their own instead of just ingesting them from different sources. Looking into this, actually, we have found that we had to rely on several data sets, government deployed, privately given, open sources, satellite data from Google Earth. A lot had to be used for this, and what we can say relation-based schema is we are trying to build here. And lack of model interpretability as well, which made previous researchers very opaque. We had to take a lot of time to understand them, which is why for our own research we used explainable AI.
Thank you from my side.
Thank you, sir.
Any other question we have?
I have no question, but I want to say something that Kaushiki, the topic you have selected, it is a very challenging topic, and I think it is very difficult to implement also.
Yes, ma'am. It is indeed
So
very
there is-
difficult to implement. At our university, we do have certain high-performance computers. We are looking forward to, lease them from time to time. The data is enormous, and now that we are actually on the future scope of this paper, we are realizing that it has been very heavy.
Mhm. Okay, do it, and best wishes from our side.
Thank you so much, ma'am.
Thank you. Now moving on, presenting the paper titled Attention Improved Wilson GRU model for distinguishing genuine and fictitious ECG signals in pacemaker-induced tachycardia under the code 388. I request Mrs. Harshita Divakar to kindly take the virtual stage and present. Over to you.
Thank you, Mehul. Good evening, everyone. This is Arshita Divakar. I'm from Bangalore. I'm pursuing my PhD under Visvesvaraya Technological University. So this is one of my PhD paper. Please give me a moment to share the screen. Yeah. Uh, so with all the people, I would like to start the presentation. So my topic is attention improved by LSTM GRU model for distinguishing between genuine and fictitious ECG data signals for pacemaker in particular condition of pacemaker induced tachycardia. Okay, so before I start with my research, this particular research, why I have taken this is, so the actual research is on pacemaker. Okay, so pacemaker is a device, implantable device, which is given to a patient who has a problem in beating of heart, arrhythmia, or anything similar to that. So normal people will get an electric signal to be that signal pulse help heart to beat. So due to some health issues, or due to some arrhythmia, or any genetic issue, or any of that situation, some people cannot produce their electronic signals, and that will not help the heart to pump. Okay, so what happens to that patients? They will implant an electronic device inside their body, and that electronic device send pulse to the heart to beat. Okay, so that is an implantable device. So since it is a device and a digital device, it is more, when it comes to a digital device, it is vulnerable. Okay, so it is easy to hack pacemaker. So now what happens? Pacemaker is sending the pulse signal, and it is producing. Now, by pacemaker's default, which happens in rare cases, pacemaker will stop working by default, or someone will hack the pacemaker and send a different kind of signals, and that will and that will make the heartbeat pump either very fast or stop pumping, or it will affect the body. Okay, now before I get into my this, I'll just briefly tell what is the working of this pacemaker. So what happens? Pacemaker sends the signals to the heart, that is the electrical signals, and heart starts pumping regularly at the regular, like a normal patient. How is ECG works? ECG is the heartbeats. Okay, so how the normal patient heart beats, it will help to beat the heart. Parallelly, it is also monitoring the heart signals, and that data is being sent to doctors. Okay, monitoring virtually. Okay, in the cloud, it is being sent to the doctors and to the patients also. Okay, so because it is cloud and it is digital device, it can be hacked, and immediately we have to take the response. Doctors have to immediately do any emergency application to stop it. Okay, otherwise the patient might declare death. So now in that, I have taken one particular condition, that is PMT condition, that is pacemaker induced tachycardia or pacemaker mediated tachycardia. We also call it as pacemaker mediated tachycardia. It is known as PMT condition, mediated tachycardia. So what happens? This is a condition where pacemaker itself will change its signal and give a high signal. Okay, so by some default thing, by some energy pulse or something, it itself gives a high voltage. Okay, I'll explain that in this thing. So what I'm doing is I'm developing an algorithm, okay, using the CNN models, to recognize whether that model, that spike, or what is the signal that is coming, is the genuine signal, that is the heart itself is reacting in that way, or due to PMT condition it is working in that way. Okay, so that I am checking in this particular paper. Okay, so how I'm doing it is, so like I explained, PMT is a condition where clinically arrhythmias are the patients whose heart does not beat normally like a normal people. They need some external support for the heart to pump. So for them, pacemaker is used, and in the pacemaker, sometimes will do a malfunction, that is, it itself gives a high pulse, and it makes the stakeholders to get the attentions or emergency signals. So now, what I am doing is, now before I first went into the paper. Anybody has done any survey or in this or not? People have done using CNN models. They have find out that there is an vulnerability, but nobody has come up with the solution till yet. Okay, because now recently the cases of pacemaker are being increasing, but 5 years or 10 years down the line it was very minute, so not much concentration was given. But now because of our whatever health issues or anything, all the other health issues are increasing, and pacemaker devices are also being In fact, in India, when I started my research, it was only 10,000 people who had pacemaker in India, and now we have 2 lakh people who have had pacemaker, who have implanted pacemaker in their bodies. So it is rapidly increasing. I mean, people are starting using. So now it is very important that we come up with something like this algorithm, so that we don't get misleaded, and because of some default, the system and the human life is at stake. So here what I'm doing is, I am reading the electronic signals, that is the ECG signals that is available, the normal ECG signals, to test this. I have selected 2 algorithm, that is by LSTM and GRU, graded algorithm. These 2 algorithms are CNN algorithm. So why I have selected this algorithm is, ECG is a time series data. It's a time series is data is continuous, and forward backward is very much included. So for that, normal machine learning algorithm or normal deep learning algorithm will not give me accuracy as compared to the CNN algorithms. So that's why I have taken these algorithm. And why I have taken 2 algorithm is for more accuracy, because PMT condition is one that gives the, that is reading the highest point. I'll
I
explain
would
in
like to
the.
interrupt. I'm so sorry for that. But your 2 minutes are left actually. So I would
Oh,
like
okay.
my
Yeah, okay. So I did a literature survey. In this, they have studied about the arrhythmia ECG pattern using CNNs. They have come up with the algorithms and tried different models, and they have got a few accuracies, and few have not tried well. So this is my proposed model, the model which I have come up with. So I'll take the raw signals, ECG signals, and I am using 2 models for more accuracy. So first, by LSTM model will filter it, okay, and then it will go to GRU model, okay, and this GRU model will help for attention mechanism. Attention is, it will only concentrate on the high voltage. See, this is the pacemaker model, where Q, R, T, these are the waves that we see. Okay, so it will only concentrate on this hike and this part, okay, this high pike part, and the remaining are not that much necessary in this condition. So the remaining things will be eliminated. The focus or highlight will be given only for these things, and it will be compared with normal ECG signal. If there is any difference, then it will detect, okay, there is a difference here, there's an anomaly here, and we have to take some action. So that is done by this. My proposed model does this. So this is how we calculate the normal heartbeat and all. Since time is not there, I'm just skipping this. So my model, I have tested with this many matrices, and and I am getting 96% accuracy. I have to still improve, because I have taken the data from Kaggle. It's not a real-time data. So in Kaggle, the data are manipulated and it is not trusty. But for going forward, I've taken this. So FN score is 96, recall is 97. So here we are looking into the effectiveness, or whether the it is real or a synthesized, like I told, created one, or the fake signal one, or it is a real one. Okay, because what happens when you're filtering the data, because of the filtration process, also the data might get filtered. So I am basically checking whether it is a real actually spike is happening, or it is a fake data. So my model will help me recognize whether it is a actual spike one or a fake data, or we can neglect it or what. So these are the limitations in future scope. Like I told, the first thing is real data I have to take. That is real time monitoring is very important. That will give me a more accuracy. And data set has to be very used. That is again a challenge because people are less to get the more data set. So as days goes, we will start working on it. So by now uh, I am concluding it that this is an hybrid architecture where I'm combining two algorithm, BiLSTM and GRU, and checking whether the PMT condition signals what I'm checking is the actual signal or the fictitious signal or fake signals. Genuine and fake, I'm finding out whether it is a genuine or fake using the I'm detecting it using my model. So thank you, everyone.
Thank you for clear and elaborative work. I would like for the questions to come up for the presentation.
Yes, Harshita, your topic is very sensitive actually, and
Yes,
the tool basically two techniques you have used, which is Bill's TM and the GRU model.
yes, yes, ma'am.
There is any other existing model exist that can perform to complete your research work? Any other topic, other model is there?
Single LSTM model is there. By
Mm.
LSTM is a GRU is there. These three singly also people have used and checked the accuracy.
Okay.
But because it is real time and it is more sensitive,
Yeah.
I am using hybrid model to be more sure. Like I said, it
Mm.
can be fake signals also, and because of fake signal, we can't take emergency decisions. So that is why I'm being more sure by combining two models. But
Okay. And
individually with by LSTM also we can get the accuracy. We will get the same accuracy.
one more question I have. In your flow chart, you have mentioned the attention mechanism.
Yes, ma'am.
What is this basically? How it is enabled?
Attention, ma'am. Like I told, the waves are there. No, usually the ECG waves. It will be too many up and down like normal waves, sinusoidal waves. Hello.
Okay. Okay.
Yeah.
Thank you,
So,
Harshita.
so sinusoidal waves will be there. But for this particular condition, we don't need the entire sinusoidal wave. We just need one particular high spike region, spike maker spike region, and a flat baseline will be there in the normal. So we are concentrating only on that spike region and neglecting the flat baseline.
Okay. Okay,
So
Harshita.
that
Thank you.
attention will give me that only this spike.
Okay.
Thank you so much
Okay.
for the questions. Now we will move to the fourth presentation, presenting the
Okay.
paper titled A Novel Deep Learning Approach for Enhancing UNSO and IOD Forecasting under the code 217. I request Mr. Rishit Agarwal to kindly take the virtual stage and present. Over to you.
I hope my screen is visible.
Yes.
Okay. So, respected chairs, all the fellow researchers, a very warm good afternoon to everyone. I am Rishit Agarwal. I am doing my master's from IIT Patna in the field of artificial intelligence. So, without wasting time, I'm starting the topic. So, climate variability today is not merely a scientific phenomenon. It is a defining force reshaping food system, economic resilience, disaster management, and geospatial stability. Today, I present our work on enhancing the forecasting of two of the most influential oceans atmosphere phenomena, that is ENSO and the IOD, that is Indian Ocean Dipole. So ENSO and IOD acts as a planetary climate regulators. They influence atmospheric circulations, ocean heat, redistributions, precipitation regimes, and extreme weather behavior across continents. In India, over 50% of the agriculture depends on monsoon rainfalls, which is strongly influenced by ENSO and IOD variability. Globally, strong ENSO okay, sorry for the globally strong ENSO events have triggered multi-billion dollar economic disruptions. So thus the forecasting these system is not only scientific, it is a socio-economic imperative. So our problem statement is, it is a long leading prediction of ENSO and IOD remains a major scientific challenge due to non-linear coupled ocean atmospheric interactions. Forecast skills declines beyond seasonal horizons, limiting action planning for agriculture and disaster preparedness. Also, the existing approaches often fail to integrate multimodal climate drivers and cross-band teleconnections. So this is the kind of research literature review where you can see that in a pie chart that how many kind of we are having a review over this deep learning and hybrid models and the quantum time series models. Mainly the forecasting that which has evolved from traditional statistical models to deep learning and hybrid architectures. While CNN's LSTM and attention-based models have improved representing learning, but still there are a lot of challenges persist in the long lead stability and multivariable integrations. So for this, there are some kind of research gaps and our model achievements that we have found. First of all is the limited long range predictive stability. Second is the fragmented multi-model integration. And third is the weak cross-based integration model. And last one is the limited structural event consistency. So our framework enhances robustness, integrates multivariable fusion, model teleconnections, and improve multitask precisions. So this is the data sets that we are using. First of all, we are using the sea surface temperature, ocean heat content that is at 300 meters. Third is the global wind speed that we are using. Then we are using Nino 3.4 index and then DMI index, that is dipole mode index. We have mentioned the resources as well, that from where we have taken the data set. And by integrating surface, subsurface, and atmospheric variables, we capture the multi-layered memory of the climate system. So this is the data set taken that we are, it is for SST kind of graphical image. It is for OHC, and this is wind speed for all the continents. And now coming to the our main methodology. So it is a kind of 5 core features methodology that we that our framework is doing. So first of all, our first feature that we are using is multimodal climate fusion. Second one, what we are using, we are doing this spatio-temporal learning architecture. Then we are having a crossband teleconnections modeling. Then we have a multitask forecasting mechanism. And last one, we are using a long lead for forecast stability optimizations. So what we are basically doing, we are using the 3 main features, that is the SST, OHC, wind speed, and then we are using the LSTM. First of all, we are normalizing and pre-processing the data, and then we are having our using the LSTM models to predict the past features as well, and predict our final output, that is the time and Nino 3.4 and DMI index. So this is our research process. So what we are basically doing, the data is pre-processed, then we are normalizing it and structuring into the multi-channel tensors. And conventional LSTM combines a convolution of spatial features, extractions, and LSTM gating for temporal memory retentions. So all the multitask dense layers simultaneously predict Nino 3.4 and DMI indices, which is improving the shape and the representing the learnings. So for the optimizations, we are using the MSC laws and adaptive gradient descents with validations monitoring to for preventing the overfitting. So these are our results where you can see the Nino 3.4 index of the actual and the predicted data sets. Here the predicted index is very much closely aligned with the actual observations, and training and validations losses converges smoothly, indicating the uh, indicating the stable learnings and the minimal overfitting. So now if you see the multi-year forecast retain realistic the variability, suggesting dynamic patterns captures rather than any kind of noise fitting. So we have some kind of evaluation metrics as well. So for DMI and Nino 3.4, there is very low MSC and RMSC values, which indicates that reduced predictions errors. And we have a high cosine similarity and structural similarity, which confirms the preserved phase alignments and event detection accuracy. And we validate the low stability demonstrates strong generalizations capability. So if you see here, this validation total loss of the GMI loss and the Nino loss that you can see it's very less now. Now, as the part of the discussion, the hybrid architecture effectively captures spatial temporal dependencies inherent in ENSO and IoT dynamics. Multitask learning enhances efficiency, consistency, and the cross-index structural stability. So at the part of the conclusion, this works advances the deep learning based climate forecasting by improving robustness, integrating a long lead stability. Also, it enhances the ANSO and IoT predictions, supports the agriculture planning, disaster management, and water resource allocations, and climate policy. So, however, we cannot eliminate climate variability, but we can reduce it to some kind of uncertainty. Yeah. With this, I thank you for your attention.
Thank you for a concise and insightful presentation, Mr. Rishit. We are open to questions now again. Session chairs, please, if you have any question, you may ask.
From my side, it's best wishes to Rishit.
Yeah, thank you so much, sir.
Please continue.
Thank you, sir. Anyone else has any question? We'll wait for 1 minute.
No question from my side.
All right, then we can come to the conclusion. With that, we conclude today's paper presentation session at UNI-TEAS. We sincerely thank all our presenters for their valuable contributions and our audience for their active participation. A special thanks to our session chairs for guiding this discussions with clarity and depth. I would now request all the session chairs participants to present and be present here and turn on your cameras for a quick screenshot for a memorable session. Vijeta ma'am. I cannot see a few who has opened. All right, just a smile would work for everyone. You all can also take screenshot from your end if someone might be missing. From my side in my screen, we'll take one more. All right, that is it. Thank you all.
Mehul,
And
do share it to me on WhatsApp, please.
yes, sir, I will surely share all the session chairs, the pictures.
Thank you. Thank you.
Thank you. And we look forward
Thank you
to
so much.
seeing you in the next session. Have a great day.
For all.
Everyone can leave now. Thank you for your time.